Let's get into number one. The expression 10 over radical 2 is equivalent to which expression? We can do this by rationalizing the denominator. We can also do this by calculator, and we can use some common sense here as well. Don't skip to the calculator explanation, because if this type of question shows up in the open-ended, you need to know how to rationalize the denominator. So I'm going to start with that method. So what that means is that the denominator right now is an irrational number. It's the square root of 2. We want it to be a rational number. The way that you do that is you multiply the numerator and denominator of the fraction by that exact denominator, by the square root of 2. What that's going to do is get rid of the irrational denominator. Why? Because the square root of 2 times the square root of 2 is the square root of 4. But the square root of 4 is just 2. So boom, just like that, the irrational denominator is gone. It's turned into a rational number 2. And then in the numerator, I have 10 times the square root of 2. Now, I don't see this in my answer choices. 4 looks close, but don't be fooled. 4 is just giving me a part of it. Don't pick that one. As a matter of fact, I would eliminate that one, because obviously 10 radical 2 cannot be equal to 10 radical 2 divided by some number. So 4 is out. But let's talk about how to simplify this further. So now, a number that is outside of the square root sign can be divided by another number that's outside of the square root sign, right? These are just integers. So 10 divided by 2, I can simplify to be 5, and I still have that radical 2 in the numerator. So 5 radical 2 is my answer here, which is answer choice number 3. Because this was a multiple choice question, you can just go in your calculator, find the value of 10 divided by radical 2, and make sure that it's the same value as 5 times radical 2. So if I hit alpha y equals enter to get me a blank fraction, I'm going to go ahead and put in 10 divided by square root of 2, hit enter, and there's the value, approximately 7.07. And now I'll do the same thing with the answer choice I picked, 5 times the square root of 2, hit enter, and there you see that those two expressions give you equivalent values, so those two expressions must be equal. This also could have been done with process of elimination, because 10 divided by the square root of 2 cannot be equal to 10 times the square root of 2. So 4 is out. And then I know that 10 divided by 2 would be 5. So 10 divided by the square root of 2 can't also be 5. And 10 divided by a number that is bigger than 1 can't give me a number that's bigger than 10. So 1, 2, and 4 made no sense and could have been eliminated from the beginning. Moving on to number 2, it gives us a parabola graphed on the set of axes and wants to know over which interval, meaning between which x values, is the parabola only increasing? When is it going upwards and only upwards? So if I look at the parabola, I know that the vertex is the turning point. That's what changes it from going down over some interval to then going up over some interval, or vice versa. So if I go to my vertex, which is right here at my blue dot, I notice that to the right of it is where this parabola is increasing, right? You always read from left to right. So going from left at the blue dot to the direction of the right, that whole highlighted area is where this parabola is increasing. It's going upwards. And so now I need to know what are the x values for that interval. So if I go back to my leftmost point, which is my vertex, the x value there is 3. So that's my starting point. And then I notice that if I try to go to the rightmost value, what I end up with is the arrow, meaning that it's going to continue in this direction into infinity. So the interval that I'm looking for is from 3 to infinity, which is answer choice number 2. Number 3, which scenario represents an exponential relationship? So an exponential relationship means that the rate of change is changing. It's not constant like it is with a linear relationship. So in a linear relationship, every week, every day, every month, the same thing is happening. A change is occurring that is exactly the same. With exponential relationships, the change changes. So something begins to grow more rapidly or decay more rapidly. So let's look at the situations we have and see where the rate of change is constant versus where it's changing. Kristen's New Year's resolution is to lose 1 pound each week. That's constant. Every week, she loses exactly 1 pound. The 1 pound doesn't change based on how much she weighed the week before or the week before that. It's 1 pound every week. That's constant, which means that this is linear, not exponential. Answer choice 2, Sarah wants to increase her grade by 5 points each quarter. Each quarter, the same thing is going to happen. It's going to be a constant change of 5 points. So again, this is also linear because it's changing at a constant rate, 5 points each time, no matter what. Tommy wants to reduce his spending by $50 each month. It doesn't matter that it's being reduced, whether it's being reduced or increased, it's still a constant change. It's still $50 every single month. So that is linear as well. And that brings us to 4, which is our exponential function. His business wants to grow by 5% each month. At first glance, you might think, well, that's constant too. It's always 5%. But 5% is not a constant value. 5% changes depending on how much money we're talking about. So if Dylan starts his business with, let's say, a $1,000 profit, then the next month, if he was going to have a 5% increase, that would become $1,050. But the month after that, so this would have been a change of $50. But the month after that, if I'm going to take 5% of 1,050 and then I add it to 1,050, that's going to bring me to $1,102.50. So this was an increase of $52.50. So you see that the change is not the same. Even though the percent is the same, I'm taking a percent of a different number. So I end up with a different number that his business is increasing by. Number 4, geometry test scores for Andrea and Joe are shown in the table below. Which statement about their test scores is correct? So we look through the answer choices so that we see what we're going to have to find. And we realize that all the answer choices are talking about mean and standard deviation. So that means I'm going to have to grab my calculator and input these values into a list. So I'm going to start with Andrea's values. So we're going to hit stat, then we're going to hit enter on edit. And now for list 1, we're just going to put Andrea's values in here. So it was 82, 87, 90, and 84. Once we have those values in, we're going to hit the stat button again. Now we're going to scroll right to calc and we're going to hit enter on one variable stats. Then we're going to scroll down to calculate and hit enter there. And now we have all of our statistics and we need 2 of them. We need the mean and we need the standard deviation. So for Andrea, the mean is going to be 85.75. It's going to be the X with the bar over it. And her standard deviation is going to be approximately 3.03. That's the standard deviation. The one above it is also a standard deviation, but that's the one that we use when we only have a sample or a subset of the data, not when we have the entire set of data. So we're going to use this one here. All right, now that we have Andrea's numbers written down, now we're going back to stat, back to edit. Now we're entering the second set of data. So we had 91, 78, 94, and 67. Same process. We're going to hit stat again, scroll right to calc, hit enter on one variable stats, and go to calculate. And now we have a mean of 82.5 and a standard deviation of about 10.78. So when we compare Andrea's numbers with Joe's numbers, we see that Andrea has a higher mean, but Joe has a higher standard deviation. And so we are reading our answer choices really carefully to make sure that we don't choose a little too quickly and choose the wrong answer. And we will see that answer choice number 3 is correct. Number 5, which polynomial has a degree of 3 and a leading coefficient of 2? So degree of 3, meaning that the highest exponent that we see in this polynomial is going to be a 3. So looking around, that means that 1 is out because the highest exponent here is a 2. 3 is out because the highest exponent here is also a 2. So now we're between 2 and 4. Leading coefficient of 2. Leading coefficient, so remember a coefficient is the number that's in front of the variable, being multiplied by the variable. The leading coefficient means the first coefficient when a polynomial is written in standard form. So it's basically the coefficient that matches up with the variable that has the highest exponent. So that means that I want the x to the 3rd power, since that was our degree, to have a coefficient of 2. And I see that that happens in answer choice number 4. My leading coefficient is 2 and my degree is 3. We are subtracting a trinomial from a binomial. What's important to remember is that subtraction sign applies to everything inside these parentheses. So you can think about it like we're distributing a -1. So this is going to be negative 3x squared plus 9 minus 7x squared plus 5x, because -1 times -5x is positive 5x, minus 4, because negative 1 times positive 4 is negative 4. And now we're just looking for like terms to combine. So we have negative 3x squared minus 7x squared. Remember that you always look at the sign that is in front of the term. So that's going to give us a negative 10x squared. Then we have 5x doesn't have any like terms. It was positive, so we're going to keep it positive. And then we have the constants, which of course are like terms, 9 minus 4, again, because we're looking at the sign that is in front of the term. 9 minus 4 is a positive 5. So this is our answer, which matches up with answer choice number 1. Number 7, the function h of x is used to calculate the average height in inches of a tomato plant x weeks after it is transplanted. These data are represented in the table below. Between weeks 4 and 12, the average rate of change is in inches per weeks is what? Rate of change we know is our slope. So we're going to write down our slope formula, which is y2 minus y1 over x2 minus x1. The reason that this problem is asking us to find an average rate of change is because the rate of change for this table is not constant. This is not linear. The rate of change is not the same. So that's why they have to tell us which ordered pairs we're going to use to find the rate of change. So they just want to know what's happening between weeks 4. Remember, x is the weeks. So week 4 and week 12. So that means that we're using the corresponding height of the plant after those weeks. So 4 weeks corresponds to 12, inches? 12 inches. And 12 weeks corresponds to 60 inches. So these are the two ordered pairs that we're going to use to calculate slope. So I'm going to go ahead and label these. This will be my x1 and my y1, and this will be my x2 and my y2. And now I'm just going to substitute into my formula. So y2 minus y1 means I'm doing 60 minus 12 over x2 minus x1 means I'm doing 12 minus 4. That's going to give me 48 divided by 8, which is 6. So that means that on average, this tomato plant is growing 6 inches per week. Number 8, Chloe is solving the equation x squared plus 5x equals 3x plus 3. Her first step is shown below. So they want to know what property justifies what she did. So let's see what she did. From the given equation to what she has, what's the difference? The x squared stayed the same. It was a 5x at first, and then it became a 2x. The right side of her equation became a 0. So that means she got rid of everything that was over here on the right side. So how do we do that? In math, when we're solving equations, the way that we quote unquote get rid of stuff from one side is by using inverse operations. So what she must have done, I'm leaving that space there on purpose, you'll see why in a second, is to get rid of that 3x, she must have subtracted the 3x from here and then also from the 5x because they're like terms and you have to do everything that you do on the right, you also have to do on the left. So on the left side, that would give me x squared plus 2x. So now I see where that 2x came from, right? It came from subtracting the 3x from the 5x. But now again, she has a 0 on the right. So that means she also got rid of this 3 over here. And the way that you're going to get rid of that positive 3 is by subtracting 3. Now, I hate that she did this in one step, but we'll follow along. So again, if you do it on the right, you also have to do it on the left. But there is no constant on the left side. So I'm just going to go ahead and put a plus 0 here so it's a little bit easier for us to see. So she subtracted 3 from that 0, and 0 minus 3 gives us negative 3, and that's where this negative 3 that she has comes in. And then all of that equals to 0 because on the right side, 3x minus 3x is 0 and 3 minus 3 is 0. And so what did she do? She subtracted 3x on both sides and she subtracted 3 on both sides. So that is going to be answer choice number 4, subtraction property of equality. Number 9, which function represents the graph w of x equals absolute value of x shifted 2 units to the right? Now, you can either remember the rules for shifting parent functions, or you can just grab your graphing calculator and graph it and see which answer choice makes it move to the right. So I'll give you the rule first. If we want to shift horizontally, we want to shift left and right, then we're going to make the change inside of the absolute value bar. So 3 and 4 are out because 3 and 4 are vertical shifts. This would make us go 2 units up, and this would make us go 2 units down. Again, because it's outside of the absolute value bars. The shifts of positive 2 and negative 2 over here, because they're inside the absolute value bars, those are going to make the function move left and right. But the rule is a little counterintuitive. Where we have a plus 2 would actually have us moving to the left. And if we do -2 inside, that's actually going to have us shifting to the right, which is the shift that this problem is asking us for. So the answer is going to be number 2. But again, you don't have to memorize that. We can just graph it and test. So go to y equals, hit math, scroll right to num, hit enter on number 1 for absolute value. We're going to put an x in there, and we can graph that first if you'd like to see it. So that's our parent function. It's an absolute value function. It is a v with a vertex at the origin. Let's go back to y equals. Let's scroll down, and we're going to hit math, num, enter again for absolute value. But this time we're going to put x minus 2. And we'll graph that to see if it really does shift it to the right. And we can see that my red function, which was the x minus 2 in the absolute value bars, is shifted 2 units to the right of that parent blue function, which was just y equals the absolute value of x. Number 10 gives us a system of equations, and it says a step in solving the system by using the substitution method would be what? So when we do substitution, we have to get one of the variables by itself, and then we replace that variable in the other equation with whatever it's equal to, right? So we substitute it with whatever it's equal to. So when I look at these answer choices, the first 2 on the left, both are equal to 5, which means that we're looking at the top equation. So to do substitution, we would have to replace either the y or the x with an expression that it's equal to. Well, I see that in choices 1 and 2, they left the 4x the same, which means that they want us to replace the y with something. But there's this random 2 in front of it being multiplied by the y, and that doesn't exist in this first equation. So answer choices 1 and 2 make no sense because that 2 does not exist in this first equation. So that can't be it. So we're only looking at 3 and 4. So in 3 and 4, we see that they're equal to 10. So that means that they were looking to substitute into the bottom equation. So what you notice is that the 2x remains the same. The -3 remains the same in both of these, but then the y gets replaced with what's in these parentheses. So we have to figure out which of these two is correct. They kept the 2x, they kept the -3, they replaced y with these parentheses. So one of these parentheses is equal to y. We have to find out which one. So let's look at the top equation and let's isolate y. We have to get y by itself, and we're going to do that by using inverse operations. So we want to get rid of that 4x, which is being added to the y. So we're going to do the opposite, which is to subtract. And if I do it on the left, of course, I have to also do it on the right side. And when I do this, 4x minus 4x is 0, so it cancels out, and I'm left with just the y on the left side equals 5 minus 4x. So now what I know is that y is equivalent to the expression 5 minus 4x. So wherever I see a y, I can replace it with 5 minus 4x. And we see that that happens in answer choice number 3. So they kept the 2x, they kept the -3, but then they replaced y with 5 minus 4x, and they kept the 10, of course. And replacing y with 5 minus 4x is fine because as we showed down here, those are equal. So answer choice number 3 is our answer. Number 11 says, which equation is equivalent to x squared minus 6x equals 27? So we can tell from the answer choices that they're asking us to do the first few steps of completing the square here. So let's set that up. X squared minus 6x, we're going to add something here, equals 27, and we'll add something here as well. So now when you complete the square, we want the constant on the other side. They've already done that for us. And now the next step to completing the square is to take half of the b term. So the b term being the coefficient of x. And we're going to take half of that and then square it. So if the b term is the coefficient of x, then the b term is -6. Half of -6 is -3. And -3 squared is 9. So once we find what that number is, we're going to add that 9 to both sides of the equation. Now, you can already see the only answer choice that's going to make sense is answer choice number 2 because it has 9 added to it. But just to finish the process, we will factor the left side. So when we complete the square, what happens on the left is we create a perfect square trinomial, which is easy to factor. So to factor x squared minus 6x plus 9, we're going to get x minus 3 times x minus 3, which is the same thing as x minus 3 squared, equals 27 plus 9. So answer choice number 2 is our answer here. Number 12, the box plots below summarize the ages of athletes on the swim team and the track team. Based on the box plots, which statement must be true? So we need to know how to read a box plot. Obviously, I'm going to label one of these for us. So the leftmost whisker is our minimum value. The rightmost whisker is our maximum value. The left kind of border of the rectangle that's over here is our first quartile or Q1. The vertical line in the middle of the box is our median or our Q2. And over here we have our Q3. Okay, answer choice number 1 says the IQR of both teams is the same. So there's some vocabulary here we need to know. IQR stands for our interquartile range. And the way that you calculate the interquartile range is by doing Q3 minus Q1. So when I look at Q3 for the swim team, it is 16. Q1 is 12, which means that my IQR is going to be 16 minus 12, which is 4. Let's do the same thing for the track team. Q3 is 14. Q1 is 10, which means that my IQR is going to be 14 minus 10, which is also 4. And so answer choice number 1 is correct. We can go through why 2, 3, and 4 are incorrect, just to go over some more terms. So number 2, there are more athletes on the swim team than the track team. These diagrams don't actually tell us anything about how many athletes there are. It just tells us, the spread of the data. So 2's out. The median average of the swim team is less than the median average of the track team. Now, at first glance, you may have selected 3. I'm glad they didn't put answer choice number 3 as answer choice number 1, because it looks like the median of the swim team is like further left than the track team, but that doesn't matter. What matters is what is the actual value of it. So the median of the swim team is 13. The median of the track team is 12. So number 3 is also incorrect. And number 4, the ranges of ages of the swim team. So range, similar to interquartile range, it's also going to be subtraction, but you're subtracting the max minus the min. That's how you find the range. The range of the ages of the swim team is smaller than the range of the ages of the track team. So the range for the swim team is going to be, the maximum was 17, the minimum is 9, so their range is going to be 8. And then for the track team, the maximum is 15, the minimum is 8, so their range is 7. Which means that the range for the swim team is greater. They say it's smaller, and so answer choice number 4 is also out. Number 13, the graph of f of x is shown below. What is the domain? So the domain means all of the possible x values of this graph. So how far left to how far right does this graph go? So when I look at the leftmost point of this graph, that's right here, and the rightmost point of this graph is right here, and I want to know what the corresponding x values are for those 2 points. So at the leftmost part of this graph, the x value is 0, and at the rightmost part of this graph, the x value is 12. So now I know that my graph is going from 0 to 12, 2 and 4 are out, and I know I have to choose between 1 and 2. What's the difference? I'm sorry, between 1 and 3. What's the difference between answer choices 1 and 3? Well, in number 1, these brackets that are on both sides indicate that both of these numbers are part of the solution set, are part of the domain. So they're included. 0 is included and 12 is included. Whereas in number 3, this symbol here indicates that the 12 is included because it says less than or equal to, but the 0 is not included because that reads as x is greater than 0. Meaning that it doesn't include 0. X can be any number bigger than 0, but not equal to 0. So now when we look at our graph, we see that the 0 has an open circle on it. And what that means is that the 0 is not included. It's where the domain begins, but it's all the numbers that are bigger than that point. It's not inclusive of the point 0, which means that answer choice number 3 is correct.